Okay, hello everyone. So this video will learn some basic concepts of optimization and how to use Excel to solve our optimization problem. Okay, so before we go to the Excel part, so let's do a quick review of all the concepts. So here I recommend one book called Engineering Design Optimization. So it's written by Martins and Ning. So it's two gentlemen from UMich, so University of Michigan. And this book is basically about all the optimization stuff on the engineering field. But so it can also be applied to the business one. So like the optimization, the solving maths, and how to formulate the problem. So that's the some general things for the optimization topic. So you can benefit from this book. So if you're interested in the optimization part, so you can go this web link. So it's on GitHub and it's free. So you just download this PDF version. So okay, so even though we are at a business school, but still, right, this means we don't like dealing with too much of the like math stuff. But here, so optimization is everywhere, and when you like graduate, you can apply all these skills to your both in your life, in your future life, or in your like work environment. So for example, so let's take several quick examples. So like firms, they want to maximize value to shareholders. Right? So when you see some word like minimize, maximize, so that's the about optimization. Okay, and sometimes we want to make some optimal choice. Right? We have several options, and the combination of them are very complex. So we are limited by maybe money, by time, and maybe other resources. So we want to make the optimal choice. And sometimes we want to the highest quality and lowest price. So when we have we want to purchase something on Amazon, so it recommended several stuff. So maybe on certain features, someone has 9 out of 10. Someone is 7 out of 10, but the price is varies a bit. So now you want to quantify the quality of the product, and you also quantify the price. So from there, you can develop a optimization problem, and you will find your best solution. Okay, so playing games, so the best strategy. And we don't have too much to do. We want to optimize the time. Okay, so it's essential. So optimization is everywhere in our daily life, and is a very usable tool. And more important, optimization is about find the optimal solution of our life. So it's kind of like a philosophy. Okay. And so mathematical optimization is nearly everywhere. So people have applied optimization in the finance area, the marketing, like e-commerce, telecommunications, operations management, production planning, so all the stuff. And here so in this course, so since we're not professional, we're not want to be the professional of optimization. So we will start with the basic concepts and the basic examples. So that's the target of this course. Okay. So let's start with the quick example. Okay, so here, in some circumstances, you may got this information. Maybe someone, your manager tell you that they want to minimize the cost, want to maximize the profit, or sometimes you want to do the product optimization, right? So we want to minimize the bill of materials, okay? But sometimes, in many cases, you will see this maximize or minimize. Right? So that's your target. That's your goal. Right? And from this paragraph, you see that you want to maximize your return and control your risk. Okay. So the optimization comes from the trade-off part. Right? If there is like no constraint, there is no trade-off, right? So we can maximize return and we don't have control the risk, right? And in that case, you just investment in the stock that with the highest returns, right? But you know, everything have the pros and cons, right? So you got the highest return, which is 10%. But you got like 15% of risk, right? Which is not good. Okay. So here, so you have your objective, which is maximize return and control your risk. Okay, so that's the constraint. So you must try to accomplish your goal, but with certain conditions, within certain conditions. Okay, and we can do so by investing in 3 stocks. Right. So for example, if we have $100, so we can, that's the maximum investment, and we can do the decision to invest a different amount of money into the 3 stocks. For example, we can invest $100 to X, right? Or we can invest like 50 to X, 50 to Y, and 0 for Z. So that's another combination. Right, so you see, so the problem starts to getting very complex because we have so many choices. Okay, and rate returns listed below. Okay, so look into this table. So display is telling the information about the decision variables. So for example, if we invest in X, we got 10% of returns from the investment, and we got 15% of risk. And if we invest in Y, we got 8% return and 2% of risk. If we invest in Z, we got 3% and 0.5% as the risk. There's so many different combinations. So basically we apply X, Y, Z. So X plus Y plus Z, that should be equal. So X plus Y plus Z should not be greater than $100 because that's the maximum. Right? We don't have like extra money to invest. So that's the one constraint. And another constraint is we want to control the risk, right? Basically, so X times 15% plus Y times 2% plus Z times 0.5%. So this value should meet this condition. So it should be less than or equal to 2%. Okay. So basically from this problem and from this table, from this paragraph, we learn some information. And the most important part of any optimization problem is to formulate the problem, because we have so many powerful tools nowadays to use to solve the problem. So once we can formulate the problem, right, because we're like not optimization professionals, so we can just let Excel, let MATLAB to solve for the optimization solution, right? So the most important part is to formulate the problem. Okay, and based on the information we have, we can formulate a problem. Okay, so it consists of 2 parts, but actually it's 3 parts. So the first thing is the objective function. So that's our target. And in this example, we want to maximize the profit. Oh, sorry, maximize return. So basically we got the equation. So we invest X dollars in this X stock. So that's 0.1 return. And plus, so the money invested in Y stock and plus the money investment in the Z stock. So basically, so the function is x times 0.1 plus y times 0.08 plus z times 0.03. Okay, so basically that's the our target, and that's also the objective function. And we have certain constraints. Okay, so the first constraint is given from the this paragraph. So we want to control the risk. So basically, it will list the same equation. So risks times the money, and this value should be greater or equal to 2%. So that's 2%. And also, sometimes we don't get the constraints very clearly from the information we know. So that's time to use some like common knowledge, right? So for example, so if we have like 100%, so we can decide the percentage that's allocated to each stock, right? That basically means so x plus y plus z cannot exceed 100%, right? Because if you above the 100%, you don't have the actual money. Right? So that's the another constraint obtained from some common knowledge. Also, another thing from common knowledge, right, is so x, y, z, can they be negative, right? So you can you like invest like minus $10 in x? That doesn't make sense. Okay, so that's another common knowledge constraint. So which basically means so x, y, z, they should greater or equal to 0. Right? And in some like order allocation or like building optimization for building a plant or for the like logistics network, so you have other physical constraints. For example, you cannot deliver minus 2 pieces of good to your customer, right? So in that case, so the variable should also greater or equal to 0. Okay. So basically from the equation, we see 2 parts, but actually that's 3 parts. So that's the this line. So that's the objective function. So we want to minimize or maximize this equation, and it's subject to certain constraints. So that's the this constraint obtained from the information given in the paragraph. And we also can obtain 2 more from some common knowledge. And also there is a hidden part of the optimization problem. So that's the changing variables, right? So we see so many combinations, right? Like invest into 3 x, y, and z. So many combinations. So basically we are obtaining the value of this function by changing x, y, and z. So that's x, y, z, that's the changeable variables. So that's the another part of any any optimization problem. Okay. So basically we got the mathematical format. We got 3 information. First, the objective function. Second, the constraint. And another hidden part that the changing variables. And in this case, so in this example, that's x and y and z. Okay, so once we formulate, okay, so 3 elements of any optimization problem. So object function, the decision variables or changing variables, and the constraints. Okay, so most of the optimization problems, they can be written in this format. So you got minimize or maximize a equation, and you got the changing variables. So x, y, and z, the changeable, right? And you subject to certain conditions. And when your constraint is like equal to 0, that's equality. And if that's like greater equal to 0 or less than or equal to 0, that's inequality. Okay, so once we formulate the optimization problem in the mathematical format, so now it's time to use, and in this course, you have like many tools online. So even though you can like do some optimization problem with the web page, or you download some professional softwares, for example, the MATLAB, or you can do like with Python. Okay. But in this course, we're learning Excel. So we're gonna solve this problem. So this problem using Excel. Okay. And okay, give me 1 minute. I need to turn on the remote computer. Okay, so now we got the optimization problem in the mathematical format. The next step, we're gonna transform that to the Excel format. So basically, we're gonna open Excel. So basically, in this course, so management information systems, so you are dealing with many systems. Right? For the example, so Excel, so MySQL, dbeaver, so all the systems. So they're computer-based. It's not like different from like the human brain. And in that case, when you're telling, so I want to solve this problem, so I want this software to help me to execute all the calculations, right? So you must use the language that the software uses. So for example, for Excel, it will only accept cells. So basically means you're gonna use cells as the character to build up your language. And the same thing in the SQL. Right? So since dbeaver only accepts the SQL language, the SQL code, so we have to tell the SQL code to the dbeaver. So as I mentioned before, so programming is a translation. So in this case, and in this example, so we're translating this mathematical stuff into some language that Excel can understand. And so let's open Excel. We open a blank worksheet. Okay. So now we're gonna put this equation to Excel. Right. So basically, we're gonna, so as the problem indicated, so first we want to identify the objective function. And so let's go back to here. Okay, so the objective function, decision variables, constraints. So basically, we want to translate all this information to the Excel. Okay, so in that case, the Excel knows, okay, so you want to minimize this style by changing these styles and subject to some conditions. And in that language, so the Excel will be able to understand and execute. Okay, so so first objective function. But before that, we want to determine the changing variables. Okay, the changing variables, let's see. So this style. Change to English mode. Okay. For example, so that's X, Y, and Z. Okay. So now you're telling Excel, so this cell will represent X. Okay, so here, X basically means this character, not the value, not the changeable thing. So this cell actually will represent the changeable variables. So these three cells, so we add some border. Okay. So here I give X, Y, and Z. So that's for increased readability. Okay, not telling Excel, so this is X. So you want to change A1 cell. No, that's so the whole thing doesn't work like this way. Okay, so X, Y, Z. I tap X, Y, Z because we want to increase the readability. Okay, and the change variables actually are the cell below them. So this one, A2. So this cell will represent X, and B2 represents Y, and C2 represents D. Okay, so that's the changing variables. Oops, all right. And now we want to tap the objective function. So that's the max, right? And also, so telling max basically doesn't mean, so we're telling Excel, okay, so that's the object function. No, that doesn't work this way, okay? That's for readability, okay? And you want to tap all the information here, okay? And here is some like little tricky stuff. So some students just tap this equation. So X times, so like X times 0.1 plus, okay. So in this case, you're telling Excel, okay, so this cell will represent this equation, okay. So Excel doesn't understand, so why you want to solve this equation, because that's something that Excel cannot understand, okay. So Excel only takes cells, so remember that. So which basically means you're going to replace the X with the cell that represents X. So it's kind of like agent, like agent stuff. So this cell is the agent of X. That's the agent of Y. That's the agent of Z. And that's the agent of the object function. Okay, so basically you're telling Excel, okay, so I will give the equation. So telling the agency cell. So this one, so times 0.1 plus, so agent Y times 0.8 plus, so this cell represents Z, so that's 0 times with 0.3. Okay, so 0.3. Okay, now it's 0. That's fine because now, so all the agents, they are empty, they equal to 0. So we got to 0. That's fine because we're gonna changing the value of this, and the max value will correspondingly change. Okay, now, so we're telling the change variables, we're telling the object function. So now we translate the subject 2, so all the constraints. Okay, so let's say, so constraint 1, so C1 here. So first constraint, so all the risks should be less than or equal to 2%. Okay, so the same thing, you're telling Excel, right? Because Excel only takes cells. Okay, do not tap X. Okay, so X is not the cell, and the Excel cannot recognize it. Okay, because we are using an agent, so use this agent cell. So that's X. Okay, so this makes sense to Excel, and if you tap X, so Excel cannot recognize it, and Excel doesn't understand why you put X, right? So it won't work. Okay, so one tap the agent cell, so A2 so times 15 plus, so agent cell for Y times 0.2 plus agent for this one and times 0.005. Okay, and we also want to make sure, so this value is less than, so it's subject to 0.02. Okay, so that's the value, constraint value. Okay, and we have another one. So constraint 2, so basically means so all these three, the summation of these three cells cannot exceed 100%. Okay, that's the physical constraint. Okay, and it's subject to the value of 1. Okay, so now we have tap everything. So we got the changing. So probably we'll ask why don't you put like x? This one should be greater or equal to 0. So all the 3 cells, it should be greater or equal to 0. Okay, because we're gonna put that directly into the solver. Okay, we don't need to tap another additional cells. Okay, so basically, so you're gonna find the solver under the data and you find solver. But if you don't see that, you can go back to insert. So insert and go to the add-ins. So my add-ins, and you go to manage other add-ins. Okay. And under the add-ins, you will see, go to the bottom of that, you see manage Excel add-ins, click on go. And now, so because of available thing, so analyze 2-pack solver, right? So you check the solver and check the analyze 2-pack and you click OK. And then you go back to data, go to the solver and click on that. Okay. So now, since we have translated the math functions into Excel, so now Excel will take the cells. Okay. So objective function, right? So this one, that's our objective function. And you select this one. And we want to maximize the return. Okay, so we click on max. So in some cases, you may want to minimize cost, then you click on minimize. Okay, but in this example, we want to max the return. And by changing variable cells, okay, so the changing all the agent, all the 3 agency cells, so A2 to B2 to C2, okay. And we do have certain constraints. So first, we want to so remember constraint 1, so this cell represents the total risks, okay? And we want to the total risks is less than or equal to this value, to 0.2. Or in some cases, we can just put so both works. So let's see. So we put 0.2, which also like add the readability, right? So you see this one. Or we can just add, for example, still the same constraint. We want to constrain this value. Okay, the same thing, but so this one will increase the readability. And we also have another constraint. So this one should be less than or equal to 1. Okay, and I'll delete this one. Okay, remember we talked about the hidden constraint. So basically, so all the changing variables, they should greater or equal to 0. Okay, and okay, so now we're telling solver. So okay, I'll tell you using the agency system. So now I'm telling the solver, right? So we want to maximize the objective function. So this function is represented by cell B4, and we want to maximize the function by changing the variable cells. That's the variable cell A2 to C2, and we also have 3 constraints. Okay, listed here. And so here, since our programming linear, specifically, so we have linear relationships between all the values. So we're gonna use simplex linear programming. Okay, so we select this engine, and now we click on solve. Okay. Okay, so solver return something. So solver found the solution. All constraints and optimality conditions are satisfied. Okay, and then we click on OK. So basically, so Excel now telling us, so you should invest 100% on stock Y and invest. So this one is so tiny, so it can be treated as 0. So you can invest $0 on X and Z, and you should invest all your money on Y, which will satisfy your constraints and will at the same time maximize your total return. Okay, I think that's it. If you still have questions about like the translation part or regarding the problem formulation or solving the problem, okay, so you can email me to make an appointment with me during the office hours. I'm happy to give you some further assistances regarding the optimization, how to use Excel to formulate to solve this optimization problem. Okay, I think that's everything for this video. And thank you for watching, and goodbye.